Hi everyone. So the goal for this video is to learn how to sketch certain transformations of the graphs of cosine and sine of this format where we have a number on the outside, multiplied by sine or cosine, and then a number multiplied by the input also. So a number times the output and a number times the input. Quick reminder of how we derived the graphs of sine and cosine. We look at a value for t on the number line, positive or negative number, that corresponds to a certain angle. Alright, either drawn in radians, either counterclockwise if it's positive, or clockwise if it's negative. The terminal side of that angle intersects the unit circle. The x component of that point of intersection is the value of cosine of that angle. The y component is the output value of sine of that angle. Alright, so we take a number which we associate with an angle in radians. That corresponds to a point on the unit circle. Technically, that's where the terminal side of that angle intersects the unit circle, and then we can find the output value for sine or cosine based off of that. And then we know we've derived what the graph or the pattern of the cosine graph looks like. Notice the scales on the pictures on the left and versus the right for cosine are not exactly the same, but the overall shape is the same. Okay, and similar for sine, we do a very similar thing, and we know our sine pattern. Okay, I've got these graphs also queued up in Desmos. So we've got the graph of sine of x here, and 5 important points we're going to key on in this video is throughout the period from 0 to 2 pi, starting point and the ending point, halfway through, a quarter of the way through, and 3/4 of the way through. For the sine graph, they're as shown. For the cosine graph, they're as shown here. Again, cosine starts at 1 when x is equal 0, goes down to 0 when x is pi over 2, then down to -1 when x is pi, back up to 0 when x is 3 pi over 2, the input 3 pi over 2, and then back to 1 when we're at 2 pi. Okay, so let's look at some of the steps for graphing certain transformations of cosine and sine. Alright, again, we're going to focus on these key points. Now, I've taken the scaling and the labeling off of there. How do we, in general, when we have some numbers A and B given, sketch one of these graphs? Thinking about sketching this by hand on paper, of course, a graphing calculator or Desmos can do that very quickly also. But one skill we want to be able to develop is just a quick sketch of the graph for various purposes. Alright, so here's the steps we want to do. We want to run through to graph it. We want to know what the amplitude is. Identify the amplitude. It's going to be the absolute value of that number. If that number in front is negative, that's also going to reflect the graph over the x-axis. Okay, but the highest points are going to be at height A. Alright, the lowest points will be at height negative A. If A is positive, if A is negative, those are going to be reversed. Okay, so these highest points here, let's assume for now the number A is positive. We're going to be at the highest points are going to be at height A. The lowest points will be at height negative A for y on the y-axis there. All right. So the one thing is to identify what the amplitude is. The next thing is identify what the period of the function is. Now I have the formula for it indicated here. The period, which most references are going to see are going to call capital P, is 2 pi divided by b. All right, what does the period mean? It's the length of the interval over which one cycle of the cosine or sine graph is completed. Let's explain that just for a second here. So normally the period for cosine and sine is from 0 to 2 pi. All right, so we want to know is for our new input value here, which is bx, when does bx equal 0? That's one question. The other question is, when does that new input equal to 2 pi? Well, dividing this on the left side of the line there, both sides by whatever the number capital B is, we would get x is equal 0 divided by b. Well, 0 divided by any non-zero number is just 0, so that doesn't change. So that means we're still starting over here at x equals 0. However, if we divide both sides of the equation on the right-hand side by b, we get 2 pi divided by b. All right, and that's indicating to us that we're going to be completing one cycle of this transform graph over the interval from 0 to 2 pi over b. Okay, so instead of going from 0 to 2 pi, one cycle will be completed on this interval, 0 up to 2 pi divided by b. All right, now b could be a number bigger than 1. If it's a number bigger than 1, that interval is going to be smaller than 2 pi. If that number b is less than 1, it'll be a number greater than 2 pi, or an interval longer than the interval from 0 to 2 pi. Okay, so we've got to know what the period is. All right, after that, our steps are to identify the 5 key points. All right, so what are our 5 key points to plot? Partition the interval from 0 to p, so from 0 to whatever your period comes out to, into 4 equal pieces, and then identify the 5 key points using the basic pattern for cosine. All right, I have them typed out on the screen there. I'm just going to go back up to the graph and kind of label that. Last thing we're going to do is repeat the pattern going left to right until we have enough of the graph sketched out as needed. But what are these key points going to be? Let's go back up here and label them. So again, we've got our period, which is 2 pi over b. If we cut that in half, we're going to get p divided by 2. And then we want to cut that into thirds. So again, the points we're going to be using is the starting point, which is 0, the ending point of the one cycle, which is the period, 2 pi over b. Halfway between is the period divided by 2. And then we want to go a quarter of the way, which is going to be p divided by 4. And then 3/4 of the way, which will be 3p divided by 4. So you cut that interval up into 4 equal pieces. At each one of those endpoints, those subintervals, we're going to have one of our standard points. And I'm just going to label those now with some big dots. So the first one's going to be at 0. It's a little too big. At 0a. Next one, quarter of the way through, we're going to be back down to 0 for your standard sine graph. For cosine graph, halfway through the cycle, we're going to be down at height -a. All right, 3/4 of the way through the cycle, we're going to be back at 0, and then fully through the cycle, we're going to be up to height capital A again. All right, and we just want to identify those 5 key points, and then we just repeat those 5 key points. So going forward, we're going to be back again, sketching these next. I've only drawn 4 of them, but going forward, another cycle of whatever the period is, or going to the left of 0, we would obtain the same kind of points, and then just connect the dots with your standard cosine graph. All right, so a very similar process for these types of transformations for sine. All right, so I got that on the next page here. And the steps are identical. Identify the amplitude and the period. The key points change a little bit because the graph of sine or cosine change a little bit. So let's just isolate and plot what those values are going to be here. So going, again, you're starting at 0, going up to 2 pi. Or sorry, up to your period, which is 2 pi divided by b. Then again, you're going to cut that interval in half, and this is your period, which we're going to call capital P. We're going to cut that in half, and then cutting that in half again, we would get p over 4. Halfway between, we would be at 3 pi over 4, or 3/4 of the period there. And then we have our important points that we're going to plot. Sine starts at 0, goes up to its highest point at 1/4 of the way through. For the normal sine graph, it's pi over 2. Back down to 0 halfway through, down to the lowest value, which is -1. For the normal sine graph, that'll be at height -a for a value where a is positive, and then back to 0. All right. So again, these heights are going to be assuming a is positive at height capital A, positive A, and then -a will be your lowest heights. So very similar, and then just repeat the pattern after that. All right, so to finish, we're going to look at a couple examples of how to plot transformations where we have given numbers A and B. I think I'm going to leave that for a second video just to keep this video short, but again, I'm just going to reiterate the steps are exactly the same. One thing to keep in mind here is that A could be negative, in which case this graph would be flipped upside down. All right, just kind of giving a quick freehand sketch of that, what would that look like? You'd be starting still at 0, but you'd be going down and then coming back up. Okay, and again, not a perfect picture there because I just drew that by hand, but that would be the idea. Your lowest points would be at A, which would be negative. Your highest points would be at negative A, which would then be positive. So again, identify your amplitude, identify the period, and that number, capital P, is 2 pi divided by B, whatever that number in front of X is. If B is bigger than 1, the period is going to be less than 2 pi. If B is less than 1, the period will be greater than 2 pi. Identify your 5 key points, and then rinse and repeat, going left and right as needed.